Hello everyone. This is the 13th video in the series of lectures on the concepts of linear algebra. In this video, I'll take up the topic system of linear equations, in particular homogeneous system of equations. Now consider the system of linear equations that is given by this. Here x1, x2 so on up to xn are variables. A11, A12 so on up to A1n. Similarly, AM1, AM2 so on up to AMN are coefficients of these variables. Then B1, B2 so on up to Bm are constants. Now the same system can be transformed into matrix form using the matrices A equal to, this is called as the coefficient matrix. By writing first row of this matrix is the coefficients of the first equation A11, A12 so on up to A1n. The second row, coefficients of second equation, mth row, the coefficients of mth equation. X equal to x1, x2 so on up to xn. These are variables. X is the matrix of variables. B equal to B1, B2 so on up to Bm, Bm. This is the matrix of constants. Now matrix equation corresponding to this system is given by Ax equal to B. This is the system of equation in matrix form. Whenever you consider a system, the system can be consistent system or it can be inconsistent system. Consistent system means it has a solution. Inconsistent system means it doesn't have any solution. In the consistent system, there are two categories of solution. One is unique solution and infinite number of solutions. And the system can be categorized as homogeneous system and non-homogeneous system. Let us see what is meant by homogeneous system. Homogeneous system of equations. The system Ax equal to 0 is called homogeneous system of equations. The right hand side, the matrix of constants is a zero matrix. Homogeneous system is always consistent, means it has solution, because x equal to 0 always becomes a solution of this system. So that solution is called as trivial solution. So the main aim of solving homogeneous system is that finding non-trivial solution. Does there exist any solution other than zero solution? So that is the aim of solving homogeneous system of equations. So mathematically, to prove that the system is consistent or it has a non-zero solution or it has only zero solution, that is categorized based on this condition. If rank of A equal to n, that is equal to number of variables, then there is no non-zero solution. If rank of A is less than the number of variables, then there are infinite number of solutions. This is the condition to find out whether non-zero solution exists or not. Homogeneous system, in case of R square, that is in case of plane, homogeneous system is nothing but it is a set of all lines passing through the origin. In case of R cube in space, the set of all planes passing through the origin. That represents the homogeneous system of equations. Let us see how to solve a homogeneous system. Consider the first example. Solve x minus 2y equal to 0, x minus y equal to 0. First, let us form the matrix of coefficients. The first row is the coefficients of first equation, 1 minus 2. The second row is the coefficients of second equation, 1 minus 1. Now let us reduce this matrix to row echelon form. So first row as it is, the first non-zero entry of first row is 1. The elements below the pivot must be made 0. So R2 changes to R2 minus R1. This is the elementary operation that I am going to perform. So 1 minus 1 equal to 0, minus 1 plus 2, minus 1 minus of minus 2, that is minus 1 plus 2 equal to 1. So now this is in the row echelon form. You have to count the number of non-zero rows. That gives you the rank of the matrix. So here rank of A equal to 2. because two non-zero rows, therefore that is equal to the number of variables. There are two variables. So if rank of A equal to n based on this condition, then there is no non-zero solution. Only trivial solution exists. So graphically, this is the way of proving it algebraically. Now, if you want to prove it geometrically, so using the graphical method, when you plot these two equations on a graph, you will get two straight lines passing through the origin. So this says that these two lines intersect at origin. You can look at the graph and you can say that other than origin, there is no other point of intersection. Therefore, there is no non-trivial solution. Only trivial solution exists. That is what the geometrical meaning of solving a homogeneous system in R square. Similarly, let us consider one more example. Solve 2x minus y equal to 0 and 4x minus 2y equal to 0. Form a matrix A, which is matrix of coefficients, 2 minus 1 first row, 4 minus 2 second row. Let us reduce this to the echelon form, 2 minus 1 as it is. Second row, I am going to change it as R2 minus 2 R1. So 4 minus 4, 0, minus 2 plus 2, that becomes 0. Now, that is because these two equations represent one and the same thing. Just second equation is a multiple of first. So now count the non-zero rows. Rank of A equal to 1. Non-zero rows 1. So which is less than the number of variables. Therefore, the system has non-trivial solution. So now if you want to find out the non-trivial solutions, the possible non-trivial solutions, you have to make one variable arbitrary. That is because here the first column, that is column of x, has a pivot, whereas the second column doesn't have any pivot. So the second variable has to be taken arbitrary value, y equal to t. Now back substitute in this values, you will get the equation 2x minus y equal to 0. So 2x equal to y, x equal to y by 2, y is taken as t, so it is t by 2. Hence, all possible solutions are given by t by 2 comma t, where t belongs to R. When you substitute t equal to 0, you will get 0 solution. T equal to 1, 1 by 2, 1. T equal to 2, 1, 2. T equal to 3, 3 by 2, 3, and so on. These are all possible solutions of the given system. This is the way of proving it algebraically. Now, geometrically, when you plot the graph of these two equations, you will get the graph like this. Means these two lines represent the same thing. They are the coinciding lines. When you have coinciding lines, each and every point is a point of intersection. Therefore, other than 0, you will have infinite number of solutions. Solution of any system is nothing but it is a point of intersection of the given lines. Now here every point is a point of intersection. Hence, you will have infinite number of solutions. This is in R square. Suppose if you have a set of equations in R cube and you are solving such equations, solve x plus y minus z equal to 0, 3 equations given. First form the matrix 1, 1, minus 1, 2, minus 3, 1, 1, minus 4, 2. Now reduce it to the echelon form. First row as it is. This is the first non-zero entry of the first row. Below the pivot, all the elements must be made 0. So R2 changes to R2 minus 2 R1. R3 changes to R3 minus R1. So 2 minus 2, 0. Minus 3 minus 2 minus 5. 1 plus 2, 3. 1 minus 1, 0. Minus 4 minus 1. Minus 5, 2. Minus of minus 1, that is 2 plus 1, 3. Now let us change the third row as R3 changes to R3 minus R2 because this is the pivot of the second column. Now below the pivot, all the elements must be made 0. So minus 5 plus 5, 0. 3 minus 3, 0. Now it is in the row echelon form. Count the number of non-zero rows. There are 2. So which is less than the number of variables. Therefore, non-trivial solution exists. And you will have infinite number of solutions. Now, you have to take the free variable. There is a pivot in first column. There is a pivot in the second column, x, y column. Now, third column doesn't have any pivot, so z is a free variable. So you can take any arbitrary value for z, take z equal to t. Now, frame the equivalent system of equations. Minus 5y plus 3z equal to 0. So from this, y equal to 3t divided by 5. Similarly, x plus y minus z equal to 0 gives you x equal to z minus y. That is t minus 3t by 5 gives you x equal to 2t by 5. So all possible solutions are given by 2t by 5, 3t by 5, t, where t belongs to R. If you substitute any value for t as 0, then you will get a 0 solution, trivial solution. T equal to 1, this is the solution. T equal to 2, second coordinate set is the solution. T equal to 3, and so on. So you will have infinite number of solutions. Now the same thing if you plot graphically, see, you will get this. This is the graph of the system of equations. They are the planes passing through the origin. Other than origin, these planes meet along the line. The point of intersection is along this line. Hence, every point on the line is a point of intersection. Hence, that becomes solution of the system. So that is the geometrical meaning. Now, one more point you have to note that if number of equations less than the number of variables, m is less than n, then there exists a non-trivial solution. There always exists a non-trivial solution. For example, x plus y minus z equal to 0. Just you have two equations in three variables, means rank of a will become less than number of variables. Therefore, automatically you will get a non-trivial solution. So you can prove it. 1, 1 minus 1, 2, 4 minus 1. Reduce it to echelon form. 1, 1 minus 1. Then R2 changes to R2 minus 2 R1. 2 minus 2, 0. 4 minus 2, 2. Minus 1 plus 2, 1. So now count the number of non-zero rows. There are 2, which is less than the number of variables. So therefore, it has infinite number of solutions. Again, first column has a pivot, second column has a pivot, third column doesn't have a pivot. Take z equal to t. So 2y plus z equal to 0, y equal to minus t by 2. Back substitution, x plus y minus z equal to 0 gives you x equal to z minus y. Therefore, x equal to 3t divided by 2, because z is t plus t by 2. So this is the all possible solutions. So when you plot it geometrically, you will get two planes passing through the origin. Whenever you have two planes passing through the origin, those two planes will intersect along the line of this intersection. So therefore, every point on the line is a point of intersection. This every point on the line is a point of intersection. Hence, you will get infinite number of solutions here in this case. So when number of equations less than the number of variables, therefore, you will have infinite number of solutions. Now, third example, solve x plus y minus z equal to 0. This is the system of equations given to you. Form the matrix 1, 1, minus 1, 2, 2, minus 2, 3, 3, minus 3. Reduce it to row echelon form. R2 changes to R2 minus 2 R1. R3 changes to R3 minus 3 R1. So therefore, you will get second row, third row, 0. Hence, rank of A equal to 1, which is less than number of variables. You will have infinite number of solutions. Now, first column has a pivot, second column doesn't have a pivot, third column doesn't have a pivot. Therefore, there are two free variables, y and z. You take any arbitrary value for y and z as t and k, then back substituting in the equation x plus y minus z equal to 0, you will get x equal to k minus t. So all possible solutions are given by k minus t, t, k. So give different values for k, you will get different set of solutions. So when you plot this graphically, you will get, see, look at the equations. They are one and the same. Second is a multiple of first equation. Third is also multiple of first equation, multiplied by 3, multiplied by 2. So when you plot them graphically, you will get a single plane. That is because all planes are coinciding. Hence, every point is a point of intersection. Therefore, you will have infinite number of solutions. Other than 0, they all have the common point of intersection as every point. Hence, you will have infinite number of solutions. So, why I have taken different examples? Because In this example, there are two pivots, one pivot and two free variables. Hence, whenever you have two free variables, in that case, when the equation, set of three equations in three variables given, two free variables indicate coinciding planes. In the previous example, you had seen one free variable here. One free variable means you will have the set of non-trivial solutions along the line of intersection. Similarly, one more set of equations. Solve x plus y minus z equal to 0, 2x plus 4y minus z equal to 0, 3x plus 2y plus 2z equal to 0. Form the matrix A, 1, 1 minus 1, 2, 4 minus 1, 3, 2, 2. Reduce it to row echelon form 1, 1 minus 1. R2 changes to R2 minus 2 R1. 2 minus 2, 0. 4 minus 2, 2. Minus 1 plus 2, 1. 3 minus 3, 0. 2 minus 3 minus 1. 2 plus 3, it is 5. So you will get 1, 1 minus 1, 0, 2, 1. I am reducing this now to 0. Minus 1 plus 1 by 2 into 2 minus 1 plus 1, 0. 5 plus 1 by 2 into 1, that is 11 by 2. Count the number of non-zero rows. There are no zero rows. All three rows are non-zero rows. Therefore, rank of A equal to 3, which is equal to number of variables. Hence, no non-trivial solution. If you plot this graphically, what you will get is three different planes passing through the origin. They have only one point as a point of intersection. Rest all places, that is here at this point, this purple plane and this brown plane meets, whereas a sky blue plane won't meet. Here's blue and purple meets, whereas the brown plane won't meet. They do not have all three together point of intersection. You don't get. In this place also, these two planes have the points of intersection. At this place also, these two planes have the point of intersection. Therefore, all three won't have any common point of intersection other than 0. Therefore, you don't get any non-trivial solution. So this is the way of solving a homogeneous system of equations. It is not just necessary to understand how to solve a system of homogeneous equations algebraically. You should know what this geometrically means. Homogeneous system in R square is the set of all lines passing through the origin. Homogeneous set of equations in R cube is set of all planes passing through the origin. Therefore, all they have 0 as a common solution. Your job is to find out any solution other than 0 solution. So that exists if rank of A equal to the number of less than the number of variables. That doesn't exist if rank of A equal to the number of variables. I hope you understood the concept. Thank you for watching.